Hello, this is Patrick Fleming, and I'm here to present the black hole lab that we have been working on in lab at Physics 1. The goal of this lab is to find the mass of a black hole using the velocity and position of a local star. This star is experiencing gravitational force from the black hole. How we plan on doing this is first by finding dp over dt using the momentum principle, so that later we can only have one constant to solve for, the mass of the black hole, in our gravitational force formula. We will already know the distance between the two, the mass of the star, the gravitational constant 6.7 e negative 11, and the net force from dp over dt. How we plan on helping ourselves find the mass of the black hole is using our computer model from VIDLE. After changing some physics in VIDLE, we will get to where we have a functional model. And when we run this model, we can see our star going around our black hole, and we can see the net forces acting on the star from the black hole. And what we end up getting is the mass of the black hole calculated from dp over dt and from our gravitational force formula. So after changing minor parts of the computer module code, we can have correct physics and correctly calculate the black hole mass and our net forces and our perpendicular and parallel dp over dt's along with the net forces. So the what does it mean question. What does it mean in your analysis? You should discuss how fnet parallel and fnet perpendicular and fnet are different from delta p over delta t perpendicular, delta p over delta t parallel, and delta p over delta t. Although equal to each other in formula, so fnet equals dp over dt, along with fnet parallel equals dp over dt parallel, the ways we find each are different. So if we go to the last slide, we can see how we find dp over dt using our computer module. How we would find fnet is by our gravitational force. So although they're equal to each other in formula, the ways we find them are different. And what if? Imagine the black holes whose mass you found were removed, and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Well, it depends for this situation. If the star's motion was unchanged, then that would mean the black hole's mass was also unchanged. In that situation, we wouldn't need to find the mass of the new black hole. But if the star's motion was changed due to a different gravitational force of the black hole, we could find the mass in the same way we found it for our first laboratory, which would just be solving for dp over dt and then using the gravitational force formula for the rest. So I thank you for watching my physics video and hope you have a nice day.